Hello and welcome to the result video of the thesis topic Structuring Behavior Data in Assistive Systems. Assistive systems provide situational support for human behavior based on information from previously stored and real-time monitored behavior data at the time the person asks for it or needs it. For this thesis, we are going to build an assistive system, and we assume that the behavior data of the user has already been gathered and stored in the database of our application. I will use this data to construct a graph structure in the backend of the application, which will be used to answer a set of questions related to the user's behavior. The application will also provide visual representations of the answers through charts. These are the technologies I used for the application. The MontiGen framework generates large parts of the application using models. I used Google Guava to implement the graph structure in the backend, and the Apex Charts library to draw charts in the front end of the application. In this picture, one can see the structure of the graph. It contains the start node on the left-hand side of the figure and the end node on the right-hand side. The start node denotes the start of the day, while the end node denotes the end of the day. All other nodes represent one activity type, such as preparing breakfast or watching TV. When two activities occur one after the other in the dataset, the algorithm adds an edge connecting the two corresponding graph nodes. In the edges, we keep information about the frequency of the two activities happening consecutively for each weekday. For example, one can see in the figure that washing dishes follows preparing lunch 6 times on a Monday, 4 times on a Tuesday, and 2 times on a Friday. We also store information from the dataset in the graph nodes. The data parameters for each node are the activity that the node represents, a list of the occurrences of the activity containing the start and end times for each occurrence, a list of how frequently the activity occurred on each weekday, and a list of durations that is used to calculate the average duration for the activity. We also store a list of how frequently the activity occurred on each household location and use this information to determine the location of the activity as the location with the highest frequency. Here one can see the list of questions that are implemented into the application and which the user can ask. As one can notice, the questions can contain 3 types of placeholders: the activity name, the day of week, and the location placeholder. The user can fill these placeholders with values to provide the context for the question. We will take a more detailed look at the implementation of the second question: what might the person do after the activity name on day of week? So now we will look at how the application determines the answer to question 2 based on the shown graph structure example. We assume the user set the activity name placeholder to preparing lunch and the day of week placeholder to Tuesday. We first locate the node associated with the activity preparing lunch as depicted in the figure. Then we iterate through the successors of the graph node as we are interested in what activities follow the activity preparing lunch. For each successor node, we check if the edge connecting preparing lunch and the successor node contains Tuesday in its edge weight. The application filters out the successor nodes in which that is not the case. To provide an answer, the application creates a table where each entry corresponds to an activity that occurs consecutively after preparing lunch on a Tuesday. The entries are based on the successor nodes and the edges connecting the node for preparing lunch with them. The application sorts the entries in descending order based on the frequencies provided in the graph edges. It also calculates the probabilities based on the frequencies. We use these to show the user the activities that are most likely to happen based on the data available. We also use the frequencies to visualize the answer table through a pie chart. This is what the final application looks like. It has 2 pages, the dashboard and the question page. In the dashboard, one can see all the questions that the user can ask organized into groups, the activity questions and the time questions. So this is the question page. This is the question box. It always displays one question at a time. The buttons previous question and next question are used to switch between the questions. And for each question, we have a drop-down corresponding to a placeholder of the question. So in this case, we only have the drop-down for activity name because that's the only placeholder that this question contains. But if we move to the second question, we see that because it contains the two placeholders, day of week and activity name, it also contains the two corresponding drop-down menus. In the drop-down menus, the data is provided from the data set, and we are going to try it out. So we're going to fill the placeholder activity name with doing laundry, and we're going to ask the question. Now the answer has been provided. As you can see on the right-hand side, we see the question with the replaced placeholders. Below it, we have a table providing the answer. We see that toileting is the activity that is most likely to happen after doing laundry with a probability of 47% at a frequency of 9. So it occurred 9 times in the data set. Below the table, we also have some statistical data, such as the number of events that the response was based on, and also the execution time for this particular answer. And below that, we have a visual representation of the answer shown in the table through a pie chart. To sum up, we saw what the graph structure looks like and how it can be used to answer questions. We also saw the final application and the features it offers. Future work includes improvements to the question structure, adding more questions, as well as using data from multiple households at the same time. Thank you very much.